Hi everyone. Today we will see the VI characteristics of MOSFET. Before dealing with that, there are mainly two types of characteristics, that is input chara and output characteristics. Input characteristics, output characteristics. So in case of input chara, we'll be plotting current IT versus VGS, that is gate to source voltage and drain current. When you're dealing with output characteristics, you'll be plotting drain current versus VDS, drain to source voltage. So here we are learning about output characteristics of MOSFET. So in x-axis, we will be plotting VDS, drain to source voltage, and y-axis will be plotting drain current, ID. So starting, the voltage given is VDS, it is 0, and slowly we will be increasing to some voltage. 1, 2, 3, just for reference I am writing here. And voltage needs to be applied across gate and source. Starting, the gate voltage is 0. So here we are taking N-channel enhancement type MOSFET. Already we are told in enhancement means there is no channel. We need to create the channel by applying voltage. And the voltage here it is source, it is negative with respect to gate, and source is negative with respect to drain. So starting this voltage VGS across, this is VGS and this is VDS. Voltage across drain and source, that is VDS. Voltage across gate and source, that is VGS. So both we are keeping 0. Or we are keeping this VGS 0. VGS voltage is 0 volt. And we are slowly increasing VDS voltage. So what will happen? We'll see. VDS, VGS is in the 0 level. VDS slightly we are increasing. So there will be some small reverse current will be there, and your MOSFET is in the off condition. When VGS is 0, MOSFET is not turning on. It is in the off condition. This region can be called as cut off state. This is cut off region. Cut off means MOSFET is in the off condition. It is not on. Your VGS voltage is 0. Slightly, I am increasing the VGS voltage to some 3 volt. VGS has increased to 3 volt, and slowly I am increasing the voltage across drain to source. So starting, ID current increases, and after some point, the ID will be constant. So here this voltage, VGS, when it is equal to or greater than VT, your MOSFET will be in on condition. MOSFET will start conducting. What is VT voltage here? VT means it is the threshold voltage. This is the minimum voltage that is required for turning on the MOSFET. When your VGS is greater than VT, the MOSFET turns on. Minimum voltage required for turning on the MOSFET, that is your VT threshold voltage. So here we can see after some point, your VGS After some point, the ID current has become constant. Up to that point, it was still increasing. Suppose you are fixing the VGS voltage to some 6 volt or 5 volt. Same thing will happen. Starting, the current will increase, and after some point, it will be constant. Still, you are increasing VGS to some 7 volt. Again, same thing. The ID current will increase, and after some point, it is constant. So this region can be called as ohmic region. This is the ohmic region. Why it is called as ohmic region? Here we can see the current ID. The increase of current ID is directly proportional to the voltage applied. ID is directly proportional to VGS. That is also called as linear region. That is just obeys Ohm's law. That is current is directly proportional to voltage. And the same time, there will be a constant resistance. Here in datasheet, we can see the constant resistance RDS on for IR of 640. It is 180 milliohms. The ID is 16 amps and VDSS it is 200 volt. This can be used for designing the circuit. So two regions you have seen, that is ohmic region and cutoff region. Ohmic region means the current is increasing linearly with respect to the voltage given. In case of cutoff, VGS is 0 and your Mosfet is in the off condition. So what about this region? What is happening here? We told after some point. So after some point, the current is constant. And this region is called as saturation region. The current will not increase further. Why it is happening? So this circuit you have seen. Before we told there is a N-type region. This is N-channel enhancement type MOSFET. P substrate is there. N plus source, N plus drain is there. So whenever an N and P region comes nearby, a depletion layer will be formed. And depending on the bias, the depletion region will increase or decrease. If it is forward bias means depletion decreases. If it is a reverse bias means the depletion region will increase. Forward bias, depletion region decrease, and reverse bias, depletion region will increase. So here also one N and P region is there. So in between some depletion region is already formed. So this N plus source is connected to negative. So this is actually forward biased. And this drain point we can see the positive is being connected to N. That is here it is actually reverse biased. So this region it is reverse biased. So what will happen when the reverse bias thing relates with depletion region? The depletion region will increase. So here the depletion region will be more, and as you keeps on increasing the drain source voltage, this depletion region will be eating the channel. That means this channel length will start reducing and a pinch off will occur at this point. The channel length will reduce. Can also be called as channel length modulation. Once the pinch off occurs, after that the channel length will get reduced in the case of MOSFET. That is channel length modulation. This is happening because of this depletion region that is eating this channel. And after this point is pinch off, VP. The voltage is pinch of voltage and the point can be called as pinch off point. So after this pinch off point, constant current, but again the current will not increase. Constant current will be flowing through this circuit. That is the region of saturation. So at some voltage, VD, this pinch off occurs. After this, ID is a constant value. You can see ID is constant value. This region is called as saturation region. This point is actually pinch off point or VP. And here, when VGS is greater than or equal to threshold voltage, your MOSFET will start conducting. Hope you have got how to draw this VI cara of MOSFET. Thank you all. We'll see in the next video. Next video will be doing switching characteristics of MOSFET.